Hello and welcome to another session in mathematics. In this session we'll be looking at geometric progression, and our focus today will be on the sum of a GP, the sum of a geometric progression. But before that, let us take a look at the previous lesson. Welcome back. We're looking at the sum of a GP today, so let us start. In our previous class, I told us that the first term in a GP is given by a small letter a, and I told us that R is our common ratio, and I told us that common ratio is determined by dividing the second term by the first term, or the third term by the second term, and so on. I also told us that to determine the second term when the first term and the common ratio is given, that what you need to do is to multiply the first term by the common ratio, and that will give us AR. Our T3 is equal to AR squared, and our Tn, I told us, is equal to A R raised to the power n minus 1. You remember? Okay, so we have the general formula for solving the sum of geometric progression to be 1. We have Sn to be equal to A into 1 minus R raised to the power n all over 1 minus R. That's the first formula. Then secondly, we have our Sn to be equal to A into R raised to the power n minus 1 all over R minus 1. Okay, we have two formulas here. This is our formula 1, this is our formula 2. Formula 1 is more convenient to be used when solving an equation whose R is less than 1. When our common ratio is less than 1, then it's preferable and more convenient that you use the first equation or the first formula. But when R is greater than 1, then you use the second formula. It's not as if the both cannot solve any problem in geometric progression, but we are talking about a matter of what? Convenience. Okay, so it is more convenient to solve with the first formula when R is less than 1, and then the second formula when R is greater than 1. Okay, quickly let us take some illustrations. We have a question here on the screen. It said find the sum of 10 terms of 2 plus 4 plus 8 plus 16 and so on. Okay, looking at the question here, what do? We first of all determine our first term, which is A, and our first term from here is 2. We determine our R, which is T2 divided by T1, and that will give us what? 4 divided by 2, which is equal to what? 2. So we have that our R is equal to what? Is equal to 2. Our N is equal to 10 from the question, the 10th term. Our N is equal to 10. So since we found this, we then have our R, and remember our R is greater than 1. So since our R is greater than 1, we use the second formula, which is this. Okay, we use the second formula where Xn is equal to A into R raised to the power n minus 1 all over R minus 1. Okay, so therefore our X10 is equal to A is 2 into R, R is 2 raised to power n, our n is what? 10, then minus 1. Okay, all over R 2 minus what? 1. This is equal to 2 times 2 raised to the power 10 minus 2 times 1, okay, all over 1, and then we'll have 2 raised to power 11 by law of indices, where if we have a raised to power m times a raised to power n, since the bases are the same, we pick one of the bases and add the powers, and therefore we'll have a raised to power, we have 2 raised to power 1 plus 10, which will give us 2 raised to power 11 here, okay, then minus 2 times 1 will give us what? 2. Okay, so 2 raised to power 11 is the same thing as 2048 minus this 2 here, okay, so we'll have our answer to be 2046. Okay, question number 2. The third and fifth term of a GP are 9/2 and 81/8 respectively. Find A, the common ratio, and B, the first term. Find the common ratio and the fifth term. So let us start. We are to find the third term. The third term is given to be 9/2, and the fifth term, which is T5, is given to be 81/8. Is that correct? Now remember that T3 is equal to a r raised to power 3 minus 1, which is equal to a r raised to power what? 2. So it means that a r raised to power 2 is equal to 9/2. 9/2, call it equation 1. And then we have that T5 is equal to a r raised to power 5 minus 1, which is equal to a r raised to power 4. So a r raised to power 4 is equal to 81/8. Okay, and this is our equation 2. Okay, so dividing equation 2 by equation 1, we have a r raised to power 4 divided by a r raised to power 2, and that will give us 81/8 divided by 9/2. So what do we have? This we eliminate this, and then we have 4 minus 2 to give us 2. So we have arrow squared to be equal to, we'll cross multiply, we have 81/8 times 2/9, and that will give us 9/4 if we multiply through. Okay, so we have that arrow squared is equal to 9/4. 9/4. Our r is equal to the square root of 9/4, which will give us 3/2. Okay, or we can leave it as an improper fraction, which is one whole number, 1/2. That's the value of our r. Then the B part of the question said we should find the first term. Okay, from the equation we have that ax2 is equal to 9/2, right? So a times the value of r now, which is 3/2, we have 3/2 squared to be equal to 9/2. So a times 3 squared and 2 squared will give us what? 9/4 to be equal to 9/2. So it means that 9/4a is equal to 9/2. Okay, then a will be equal to 9/2 divided by 9/4. Is that correct? So a is equal to 9/2 times 4/9, right? And this will cancel this. We'll be left with 4/2. 4 divided by 2 will give us 2. So a, which is the first term, is equal to 2. Okay, one more example. If 7p Q and 56 are in GP. Find P and Q. Find P and Q. Okay, let us start. Our A, which is the first term, is 7, and the fourth term, which is T4, is equal to 56. Is that correct? And T4 is given to be AR raised to power 3. Is that correct? So that means that AR raised to power 3 is equal to 56, but A is given to be 7. So 7R raised to power 3 is equal to 56. Now R cube is equal to 56 divided by 7, and that will give us 8. So R raised to power 3 is equal to 8, and R then will be equal to the cube root of 8, which is equal to what? 2. So our R is 2. Now we found the value of what? The common ratio. So, and we told us that the second term is equal to T2 is equal to A times R, which is equal to AR, where our A now is 7, our R is 2, so T2 is equal to what? 14. Then P is equal to 14. Q is our T3. Our T3 is equal to AR raised to power 2. So we have A, which is 7, times R, which is what? 2 raised to power 2. We have 7 times 4. Okay, and 7 times 4 will give us 28. 28. So our Q is equal to 28. Okay, to refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to cover the sum of a geometric progression. We'll stop here for today. So do well to use the lesson notes on the platform for better information on what we've just done, and feel free to leave your comments or questions on the comment section. Till we meet again in our next class, stay safe and bye.